we either have builders come up to us and say, look, I want to achieve a building that is 30% better than code. Or I want to achieve passive house buildings in the way that we build. So if we want to do 30% better, we work with this builder. We usually call this builder who wants to achieve something above and beyond code a conscientious builder. Somebody that other builders look up to move in the market space and have higher performance buildings available to homeowners. So we work with them hands in hands. We have design meetings. We sit with them and look at the overall system. Okay, and then when we look at the overall system, we look at how to achieve, what are the elements that are most important for that particular climate zone, for that particular building, using the preferences from the builder. For example, if a builder likes to use a double-studded wall, like the example with Newtown Homes, when we met up with Gene Myers, who is the president of that, he was a builder, president builder. He approached us and said, Achilles, look, I really want to take it to the next level. I want to do buildings that are norms. The norm of my construction should be zero energy. I want to do that in a cost-effective way. So we sat down with Gene and we went through the whole gamut. We also went to a level where we talked to Gene about, look, we're going to provide you with a system that enhances the comfort. Radiant mean temperature is a very important element in our design for comfort. And what does that mean? I mean, you sit in a building and you sit in the middle of the room and you have now all the surface of that building is radiating to you. And as you have that radiation exchange that happens, that you feel it. I mean, that's how in some buildings that even though you have an R20 in the walls, if you didn't do a good job at thermal breaking that wall, you're going to feel uncomfortable. So what we said to Gene, look, you're using these double stud walls. Why don't we stagger them? Why don't we minimize the thermal bridging on that? Now, guess what happens? Now, in the middle of these buildings, and we've heard, and it's been documented by Gene, that a lot of these homeowners are loving these buildings because now they feel the comfort. I don't think many other builders in the country as well as in the world are designing for comfort, but we've sort of come to that point that we can offer that as a solution to those builders who want to achieve and go beyond code. The best way to integrate efficiency, comfort, durability is right at the front of the design aspect of it. That's way in the beginning of the design where we work with architects and coming up with the best and the most optimal design to achieve comfort, energy efficiency, durability. And that's obviously always the best way to do it. For example, demising or partition walls. I mean, there is so many great things that we can do and help the framer, the framing design that allows us to block the access of that airflow that could be moving from the outside way through into the walls by us properly getting involved and helping out and deploying that. So absolutely, we need to be there before any framing is happening. We need to be there during the design stage, get a better value for what they provide. The worst thing to happen is the builder get that call back saying that, look, I have now moisture problems with my wall. I have paint that's peeling. I got musty smells. I have a problem in my hands. And that is the worst nightmare for a builder because there are costs involved in that, but also it's that reputation. That is where the builder needs that building science. I mean, and I think we've come a long way. The last several years, there's been a major shift, and builders are the persons that are those folks that are pursuing us. I mean, our relations with the builders are in a way that, I mean, they love to interact with us. They love to work with us. I've worked with a couple of hundred builders, and all of them are just eager to spend time with us. I mean, usually it's hard to get builders to find some time to work with folks, but you talk to them, you tell them, look, I'm OC and I'm from building science team, and their arms open up and they want to work with us and they want to bring us in and to keep us in. So I love that because at the same time, we learn a lot from them as well. We'll tell the builder the absolute truth. If a wall system can be done better using a competitor's products, we will let that builder know that that's the way to go. Because at the same time, we believe that a builder is our partner. With Newtown Homes, the way that they were laying out their floor joists were such that there was a very difficult spot, and there was a very difficult spot to be able to sort of air seal. And that became a thorn in the beginning, the first house that we did. And we sort of sat down with them and said, oh, well, how about changing that the way that you put, how to change slightly, a few inches in your design, floor design, so we can have enough space to air seal it. Give us enough bay space like what you have everywhere else throughout the building. Give us enough space so we can do a proper air sealing job. And a few inches of space was all that was needed. We got it. The builder's happy. The air tightness is extremely better than what we had first round. So, I mean, there's a lot of learning that comes about in this whole process. As Achilles, I'd like to move even further, and I'd like to have buildings that supply energy for other uses in our lives. Like, for example, cars, and for example, all the electronic devices that we all carry around with us every day. And I think that would be a plus energy building, providing more than what you consume for the building, but also providing you enough energy to do other things in your life. And in order for you to achieve that, you need to have a robust envelope with high energy efficiency embedded in it. You can go plus homes that will provide all of the energy that you need to function in this world. And if you look at how much we need, I think, 230 watts per day. Kilowatts per day. 230 kilowatts per day for somebody living in North America. How are we going to generate that amount of energy in a way that is sustainable? So I think one way to achieve a big chunk of that is to deploy our house as our energy source, providing us with all the energy that we need to sustain ourselves. And I think there's a long way for us a long road, a long path to achieve that, but it's going to be within our reach in the near future. We have tools that are everyday use, and those are tools that look at the thermal bridging in 1 dimension, 2 dimension, 3 dimensions. We have tools that look at vapor and liquid transfer in 1 dimension, 2 dimensions, 3 dimensions. We have very sophisticated computational fluid dynamics models that allow us to look at all sorts of integrated systems approaches. We also have tools that look at energy performance at the component level, like a wall, roof, and basement, or we have tools that look at the whole building, like Energy Plus, like some of the simplified REM rate softwares that are used now to provide Hurst scores. So we have a slew of things that we use for different applications. We have this unique ability to sort of go into the high-end analysis at a very relative low cost in terms of time that we need to use to deploy these software tools. And the reason is because the team, as well as myself, we're 100% on board on the software tools, and we have quick turnarounds. And that's what we use a lot on our comfort-built homes, where we deploy our high-end tools to analyze not only the durability aspects of it, not only the mold growth risk, not only freeze-thaw opportunities that might happen, not only corrosion that might happen in steel studs, and wall systems or basement systems or roof systems. We have the ability to integrate that and do a one-shot deal when we analyze that. I don't think any other not even consulting companies do that, but I don't think any other manufacturers have that bandwidth to carry out analysis to that level with very short turnaround time. Looking at elements in that building system that we can use our products more effectively in. For example, in that high-performance attic system, we've understood the value of having our ducts and our mechanical equipment in the conditioned space. So we said, well, let us develop an innovative way of adding insulation, and we've done that through a new system, a box-netted approach system, where we can come up with now an unvented attic that performs amazingly well, that doesn't have the stigma and the failures that possibly some of the other insulation used in an unvented attic, for example, spray foam, in a hot and humid climate with small amounts of water coming through the sheathing and now getting trapped there and not being able to dry out. Well, we don't have that problem. That failure issue is not there for us. So we've come up with an innovative way of coming out with these unvented attic systems that allows us to inject a lot of forgiveness in our attic system that were not there before with other insulation systems. So I think we always seek ways to increase the overall performance of a building, and for example, a good example is that unvented attic